So today we are going to cover Python Pandas and we'll be doing data handling and visualization both. As you can look at the title slide, in the title slide, you can see we have an example where we have 1D data in which there is a series in which our names are written and C1, C2, C3 are acting as indexes. So that is contributor 1, contributor 2, contributor 3. In the second example, second panel, you can see there is an example of data frame where we have 2D data. So we have date, we have meet count and topic of the meet, and schedule is the index. So you can see in place of index, that is row header, you see schedule. On the column header, you see date, meet, and topics. As far as CBSE curriculum is concerned, this is what is there under revised curriculum, that is data handling and visualization, introduction to Python libraries, pandas, and Matplotlib, data structures in pandas, series and data frames, series, creation of series from ND array, dictionary, scalar values, mathematical operations, head and tail functions, selection, indexing and slicing, data frames, creation from dictionary of series, list of dictionaries, text or CSV files, displaying the content of data frames, iterations, operations on rows and columns such as add, select, delete, rename, head and tail functions, indexing using labels and Boolean indexing, importing and exporting data between CSV files and data frames. Now here in this content, you see we have ND array. So we'll be covering in brief little bit about NumPy also. Data visualization we'll be doing. Under that, data visualization, purpose of plotting, drawing and saving following types of plots using Matplotlib, line plot, bar graph, histogram, customizing plots, adding labels, title, and legends in the plots. It is suggested that you first install pandas, and for installing pandas, you will go to the command prompt and type pip install pandas. Now, best thing about installation of pandas is as soon as you install pandas, these bundled packages are also installed along with it. One is NumPy, PyTZ, dateutil, and 6. So as soon as you type pip install pandas, you will see all these packages are installed automatically. So you don't have to write separate command as pip install NumPy. If you are installing pandas, NumPy automatically gets installed. At the end, you will get this message in which NumPy along with the version, pandas along with the version, dateutil along with the version, and the last one, 6 along with the version will be shown to you, right? And these versions should be appropriately aligned with your Python installed in your system. So if you have downloaded Python recently, then your pandas are going to be installed automatically with the latest version only. Now, as I told you that we are going to start with NumPy because NumPy is basically 1D and 2D array collection. Later on, when we'll be doing series and data frames, we'll be having customized labels. In NumPy, we have automated labels. That is the major difference between the NumPy and pandas. NumPy is a Python package. NumPy is a library consisting of single or multi-dimensional array objects and a collection of methods or functions for processing of arrays. NumPy is the fundamental package for scientific computing with Python. Dimension in NumPy arrays is known as rank. NumPy package was created by Travis Oliphant, incorporating the features of num array, which was introduced before, into numeric package. Apart from Travis, many other contributed in the open source project of NumPy. So right now, there are many people working on the NumPy package together with Travis. Now, when we talk about NumPy, NumPy is basically a numeric array. We can make 1D array, 2D array, or more than 2-dimensional arrays. So this is a very, very simple example showing you 1D array as well as 2D array examples. So you can see with the help of a simple list in Python, you can convert it into an array just by writing a is equal to np.array in bracket, square bracket, 10, 20, 15, 5, square bracket close and round bracket close. So this is going to be a 1D array. So after this line onwards, a will be treated as NumPy 1D array. For 2D array, you can make nested list. So you will be having this as the first row, this as the second row, and this as the third row. So there'll be 3 rows and 4 columns in the 2D array. So you can see this is the example showing you the same. Now, if you look at the 1D array, on top you see 0, 1, 2, 3. These are the default indexes automatically get assigned as soon as an array 1D array is defined. When you write a 2D array, there'll be one row index and there'll be one column index. So these are going to be treated as column index and these are going to be treated as row indexes. And these are automatically assigned and we can't customize them, right? Mainly NumPy is used for numeric operations. So anything which is scientific or mathematical in nature and you have to analyze that data, you'll require NumPy. NumPy is very, very useful for bulk operations, right? So you don't have to run loops for iterating on different values. In this, one single operation can help you to modify the entire content of your NumPy array, whether it is 1D or 2D. We will look at the examples in the later slides. Right now, as I told you that this is going to be 1D array and this is going to be 2D array. And if I display the content of A as it is going to be displayed like this. The difference between the display coming from list and display coming from array is that you notice there is no comma here. So when it is coming from NumPy array, the content is going to carry no comma while displaying the content. Next to that, we are writing a.size. Size is going to count the number of elements and number of elements here are 4. When you will say a.shape, shape will be a tuple in which each dimension's number of elements are mentioned. So in this case, it is a 1D array. So it will have only one dimension and total number of elements are 4, right? This comma shows that it is a tuple inside the round braces. For the second array, instead of displaying directly as print B, I have used a 2D array example as 2 loops. In this, I am writing for I in range b.shape 0. So as I told you, shape is going to be a tuple in which each dimension's total number of values are stored one after another. So if I am saying b.shape 0, it is going to be number of rows and b.shape 1 is going to carry number of columns. So accordingly, if I run these two for loops, one inside the other, it is going to display the values in this manner. These spaces are coming because I am writing here and is equal to space, right? These are not default display. This is customized display. So in which each element of the array is displayed one after another, and as soon as one particular line gets over, this print statement terminates the line and displays the rest of the elements in the next line. So that is the reason here in one go it is getting displayed, and here this is a customized way of displaying a 2D array, the way we have been using in C++. Exactly in the same manner, we are trying to display our 2D array, and instead of using n and m, we are making use of shape to give us the number of rows and number of columns in it. This is another example where you can see how we can add content in NumPy array. The size of NumPy array is as such fixed. It cannot be changed. But yes, you can overwrite it. You can dump the content modified in another variable. So let's assume we have right now 3 elements in this particular array, and if we are displaying it with the help of this for loop, each of these elements will be displayed with a separation of hash symbol. With the help of this print, this line gets terminated, and after this, if I say np.append a comma and 2 elements over here. So as soon as you do this, the result will carry 10, 20, 15 along with 25 and 5 in it. Then if I display the content over here, the content of A will be 10, 25, 15, 25 and 5. If I say a.size, it is going to be 5. A.shape will be a tuple with only one dimension mentioned over there. Next to this, if I am saying np.delete, and first parameter I am passing the array, and I am saying that delete first and third elements. So first element is going to be 20 and third element is going to be 25. So that will vanish from the array. So after this, if I display A, it will carry only 10, 15 and 5 because 20 and 25 got deleted. So these 1 and 3 mention the indexes. So we have removed first and third element from the array. So whatever is remaining is going to be 10, 15, and 5, and 3 is going to be the size of this particular array. Next to this, if instead of using append, if you want to use insert, you have to specify where what to be inserted. So we are saying in the array A, in the second index, insert 12 and 14. So you can see the second index is this. At this index, 12 and 14 got inserted. And then if I am displaying A and size, obviously the size is going from 3 to 5. And you can notice that the value which was stored on the second element has shifted to the fifth element, because at second element 12 and 14 got inserted. So here we can use list as well as tuple. Both of them will work exactly in the same manner. Now a quick review. Append returns an array with values or collections added at the end of the array. Delete returns an array with values or collections deleted from the specified indexes of the array. And insert returns an array with values or collections inserted in given indexes of the array, shifting all other elements to the higher locations. So that is very important to know. Next, the best thing about NumPy array is relevant of how many elements are there. You don't have to bother about the count of number of elements. If you simply write these simple functions like sum, mean, max, and min, they are going to calculate the result in fraction of second. So as soon as you have an array and you simply write a.sum, it is going to return the total of the values which are stored in the array. Mean will calculate the mean, max will find out the maximum value out of it, and min will find out minimum value out of it. So irrelevant of whether it is 1000 elements or 1 million elements or 2 million elements, it is going to give you the result in no time. Now, best thing about NumPy array is the bulk operations on individual elements are also extremely simple here. So you can see here 10, 20, 16, 20 is the content of my array A. And if you want to add value 2 in each of them, you can simply write A plus n. So in each of these elements which are there in the array, 2 will be added. So you can see here, so if I am writing A plus 2, it is going to be 10 plus 2, 12, 20 plus 2, 22, 16 plus 2, 18, 20 plus 2, 22. In the same way, you can see multiplication is also taking place. 10 into 2, 20 into 2, 16 into 2, and 20 into 2. Okay. Integer division also you can perform. So 10 divided by 2 is going to be 5, 20 divided by 2 is going to be 10, 16 divided by 2 is going to be 8, and 20 divided by 2 will be 10. Raised to power also works fine. So 10 raised to power 2 is going to be 100, 20 raised to power 2 is going to be 400. So you can see right now I am giving you an example where we have only 4 numbers. Now think about if you have 4,000, 4 million, 4 billion numbers, it is going to be as quick as it is done with 4 elements. So that is what is power of NumPy, right? So bulk operations broadcast happens very, very fast in NumPy. Now, as the scalar operations work very well here, the vector operations also work very well. That means if you have 2 same sized array and you want to perform addition operation, the corresponding elements will be added in no time. So if you have one array with 5, 8, 15, 20 and second array as 5, 4, 3, 2, you can have all these operations on corresponding elements within no time. So you can see here 5 plus 5 is 10, 8 plus 4 is 12, 15 plus 3 is 18, and 20 plus 2 is 22. Not only addition, but all operations which are arithmetic in nature will happen exactly in the same manner. Now, as you know, NumPy was quite in brief in the curriculum, so that is why we did not emphasize further on that. Next, we are going to cover Python Pandas. So before we move to Python Pandas, let's know a little bit about Pandas. It was Wes McKinney, American software developer and businessman, who created Panda packages as open source project, right? And the purpose of creating this Panda package is for data analysis and many other data related projects. So this Wes McKinney also authored 2 versions of the reference book of Python for data analysis, which are very, very popular book. And I would advise and suggest all of you as teachers should look at the books. Even if you look at the online version, that will be pretty good because it gives you pretty good idea about what data analytics is all about. Now, what is Pandas? Pandas basically is high-level data manipulation tool. It is a free software released under 3-clause BSD, that is Berkeley Software Distribution License, built on the NumPy package. Its key data structure is the DataFrame. DataFrames allow us to store and manipulate tabular data in row of observations and columns of variables. In today's time, it is the most important tool at the disposal of data scientists and analysts working in Python. Right now, 90% of the programmers make use of Pandas for data analytics. The first thing what we are going to do in Pandas is the 1D data structure, that is series. Now, before we move forward, I would like to tell you that NumPy and NumPy array and the series of Pandas have a very little difference, and that difference is in NumPy 1D array, we are not allowed to tamper with the indexes. And here in Pandas, we are allowed to give a customized our own indexes with the elements. So this is the syntax which we are going to follow. So we'll be writing pandas object.series. Series S is capital here. In bracket, you write data. Then you'll be specifying the customized index. If you do not specify the customized index, the default index is going to be similar to NumPy array index, that is 0, 1, 2, 3, 4 up to n-1. Then you can specify data type, and then you can have Boolean value as copy data. The default of copy data is false. These are few very simple examples where we have a single value as a tuple creating a series. So you can see here, we are writing import pandas, s is equal to pandas.series, in bracket we write 20. So we have created one panda series with one single element. So if I display it, it is going to display 0 as the index value and 20 as the data in it. And the data type of 20 is going to be displayed as int64. Now, these are the 3 different variations in which the series can be created. You can write from pandas import star, and instead of writing anything before series, because we are saying import star, it is going to consider all the functions which are lying inside pandas to be directly used without prefixing anything before it. So we can directly write s is equal to series, and inside bracket 20 means we are keeping one single element in it. The third example, which is the most common example, which all of us use, is import pandas as PD, and then we write s is equal to pd.series 20. Now, why we do not use this example? The reason is very simple. In this case, every time in front of every functions of pandas, we have to write this big name panda. Now, the second question is, why do not we use this one where we don't have to prefix anything in front of the name of the Python function? We do not use this because there are number of Python pandas functions which are common to other built-in functions. So there should not be any clash between the two names, and that is why we prefer not going for this option also. We only use this kind of options in which we keep preserving the original built-in functions as well as pandas function as a separate part, right? However, all these 3 examples will give you the same result. Okay, we'll prefer the last one. Okay, next, look at the second example. In the second example, I am trying to repeat the previous example. Here, without putting any bracket, I am writing 20, 30. As soon as this is going to come, it is going to be type error, because here inside the braces, it is expecting you to specify a single collection as the data, another collection as indexes. So right now 20 as well as 30, both of them are not considered as collection, and that is why the type error will be encountered. So if we want to correct it, I have to put one set of round braces around 20 and 30 so that it will be considered as a series. Okay. In the next example, you can see instead of tuple, we have a list, converting it to turn into a series. So you can see 0 and 1 are the indexes and 20 and 30 as the values stored inside this Panda series. The next example, instead of having this list as a constant over here, we can store it in a variable and we can make use of a variable. Both of these examples will give you same result, but we should prefer going by the second option in this case. Next example, we can have dictionary also acting as series. So if we are submitting a collection as dictionary, so what will happen here? A and B will automatically be treated as indexes. 20 and 30 will be automatically treated as data values. Now, look at the second example, which is going to give you the same output, but here we are considering it as a dictionary. Here we are considering 20 and 30 as the data values and A and B as the indexes. So you can see A and B appear in the first column. That means these are indexes, and 20 and 30 appear in the second column, which are data values attached with these indexes. And both of them are belonging to int 64 as the data type. So basically both these examples make the same sense. Next, if we want the named parameter over here, if we want index to be written before, so I'll be writing index is equal to 20, 30. Normally, the original order is that whatever collection is coming before is going to be considered as data, and whatever collection is coming later is going to be considered as index values. But somehow, if you want to put index before, then you have to make use of named parameter, where you'll be writing index is equal to 20, 30 and data as A, B. So this, in place of the first column, you'll see 20 and 30, and the data values will be A and B. So if you want this example to be done with positional parameter, then in that case, you will be placing A and B before and 20 and 30 later. And then only you will be able to see 20 and 30 acting as index values and A and B acting as the data with each index. Okay. This is another example where we have NumPy array getting converted into series. So you can see NS is a 1D array in which A and B are stored, and we have a series in which NS is going to be the data, that is going to be A and B, and 20 and 30 are going to be treated as indexes. What all operations, that scalar operations, we can perform here? So we can have plus, minus, multiplication, division, integer division, remainder, and power. Now, either we use plus or we use add, it will make the same sense. Either you use minus sign or you use sub or subtract, it will be same. You use star or MUL, it will work exactly in the same manner. You use division sign or you use div or divide, it will be of the same meaning. Now, why at all we'll be using these functions if these simple operators also perform the same? Reason of that is, if at all, if your data is carrying some none values, none means not existing values, in that case, that can be substituted with some other value with the help of this function, whereas the standard operators will not allow you to do so. Okay, so this is very important for you to understand. In spite, plus and add do the same thing, minus and sub do the same thing, we still prefer going for function or methods, because that can help you to substitute none values with something else. Then apart from those which can work as vector, we can have some more functions as scalar as well as vector. One is sum. So you should know the difference between add and sum. Add adds two corresponding values, whereas sum adds all the values in one particular series. Product add all the values within a particular series. Mean finds the mean of all the values within a series. Max finds maximum value out of the values given in a particular series. Min finds out the minimum value which is there out of the values present in the series. Count counts the non-null or non-NA values in the series. So if you have 20 indexes in a series, it is not necessary there will be a 20 values. It might be that some of the indexes carry data value as none. In that case, the count is not going to add them in its count. Apart from this, you have three more functions. One is head. Head gives you the upper portion of the series. Tail gives you the lower portion of the series. If you do not specify the value of n, then in that case, n is treated as 5. That is, the top 5 rows will be displayed. In tail, bottom 5 rows will be displayed. If you write along with head, if you specify 2, then top 2 rows will be displayed. If you write tail 2 as the parameter, in that case, last 2 rows will be displayed. Now, if you at all you want the sorted series, in that case, you will be making use of sort underscore values. And if at all you want it to be in descending order, then you will be writing ascending is equal to false. By default, it is going to be true. Now, let's look at some scalar operations which we discussed. If at all you want this series final and 5 to be added with these all values. So 13 plus 5, 18, 16 plus 5, 21, 14 plus 5, 19. In that case, we will make use of plus sign. So you'll be writing final is equal to sub 1 plus sub 2, assuming this is going to be added to each of them. In this particular case, you can see we have vector addition. So 6 plus 7 is 13, 7 plus 9 is 16, 8 plus 6 is 14. So in this case, if at all none comes, it is going to result in NaN, that is not a number. So if you are using function, this can be taken care of. Right now, it cannot be. Now, let's look at this example. First of all, let me show you the previous example. In this case, we are adding, that is 13 plus 5, 16 plus 5, 14 plus 5. And the corresponding results come here. In this case, when it is none, you can see none plus 5 became not a number, right? In case of vector, the same kind of problem occurs. When we write none plus 9, it becomes not a number. Now, to take care of this problem, what we need to do? We need to make use of add function. So in case of add, you say that wherever none is encountered, that needs to be understood as 5. Or you can say any number over here. You can say 0, right? So if final dot add, in place of using plus symbol, if you are making use of add and you write fill value as 5, it is going to be replacing this none with 5. So it is going to be 5 plus 5 as 10, and remaining values will be adding in the normal way. So that is the reason whenever you think that there may be some none values, instead of using plus symbol, you should make use of add. Same goes for vector addition also. In vector addition, you can see we are saying fill values as 5. So it is going to be 9 plus 5 is going to be 14. Next, append and drop on series using pandas. So you can look at this example. We have right now 3 numbers in the series, which is named as ENG1. And for each number, we are associating index as names of people. So Ami has 6, Jay has 9, and Ken has 7. We have one more panda series, which is ENG2. In ENG2, we have only one index and one value. So if we are appending it, it is going to be along with 697. So it is going to be displayed as, when you'll display, it is going to be 6972. And in index, Ami, Jay, Ken, Kane, and Pran. So these will be displayed. So you can notice we have created second series in which there was one data value and one index that got appended at the bottom. After this, if we say ENG PIA is equal to 5. So right now there is no PI existing in this particular series. So what will happen? a new row will be added in the series where the index will be Pia and the value will be 5. And then we say eng.log pran is equal to 8. So right now pran is containing 2 as the data value, that will get replaced with 8. And after this, when we'll display the value of eng, it is going to be like this. So you can see Pi is added with 5 marks over here. This is what we did. And then pran in place of marks as 2 is changed to 5. After this, suppose you give a command as eng is equal to eng drop ken and Pia. So ken and Pia, both of them are indexes. So ken will be deleted from here and Pia will be deleted. So what will be remaining here? The remaining elements will be containing all the names and marks except Pia and ken. You can see Ami 6, Jay 9 and Pran 8. So all of them are there except. So this explains you the concept of how to add new elements in the series. It can be done either using this method in which you create a separate series and append it with the help of append. Second method is you simply find out an index which is not existing, put that index and put the value along with it, and this particular line will help you to add a new row in the series. In the same way, if you have to update something, then you can specify eng.log pran is equal to 8. So it is going to look for pran, and wherever the pran is found along with this index, earlier the value was 2, it will get modified to 8. And if you at all you have to drop, then you have to specify the indexes over here, and corresponding to indexes, the data will be removed from the series. So this particular slide is all about append, drop and add new values in the series. Now let's look at simple operations which we have already seen in the diagrammatic representation. Now look at this, where we have Ami, Jay and Pran as the indexes and 6, 9, 8 as their values in ENG and 7, 9, 6 as values in MAT. So you can see here, if I am writing index is equal to IN, in both the cases, in both the series, our indexes are same and the indexes are in the same order, that is Ami, Jay and Pran. And in first case, when ENG is there, Ami is having 6 marks, Jay is having 9 marks and Pran is having 8 marks. Whereas in math case, Ami is having 7 marks, Jay is having 9 marks and Pran is having 6 marks. So if we simply write final is equal to ENG plus math, it is going to add marks of English as well as math. So first of all, let's see what is the content of English. This is how you will see the English marks, and then the content of ENG is going to be like this, where the marks of English are listed. Second, if we see the content of maths marks, it is going to be 796. And if we look at the final marks, it is going to be addition of the corresponding elements. So basically, their indexes are matching, and that is why 6 will be added to 7, 9 will be added to 9, and 8 will be added to 6. In the normal circumstance, if at all index is not specified by us, these indexes would have been 0, 1, 2. And in this case also, the corresponding indexes would have been 0, 1, 2. And the similar kind of addition would have taken place. So whether it is customized index or it is the index which is by default provided in series, both cases, it is going to work exactly in the same manner. Next, we can perform certain operations also. Let's assume once again we have Ami, Jay and Pran as the index values and 13, 18 and 14 as the final marks. If you want to give raise of 5 marks to each child, so you can simply write final plus equal to 5. So in the diagrammatic representation, if you recall, you saw that each marks got added with 5. So this is going to be scalar operation. It is going to be, so if you look at this example, if I say final marks are going to be 5 more than what was already existing. So 13 plus 5, 18, 18 plus 5, 23, and 14 plus 5, 19 got displayed. After this, when we are calculating percentage of marks and then displaying it, you notice 18 is out of 25. So it is converted from 100 So percentage of marks are calculated for each child out of 100 now. So all these marks which are obtained here are out of 25. So what we did with the help of this single formula, we have converted each value in out of 100. So you can see here percentage of marks obtained by each child. Once it is done, you want this result to be displayed in descending order or ascending order. So in this case, we would like to display it in descending order so that merit comes with topper on the top. So you can see 92 is displayed on top, then 76 and 72, and corresponding to marks, you can see the indexes also rearranged. So you can see 92 on the top. 92 is basically Jay's marks. So Jay has come on the top. Then 72 is marks of ME, and ME is coming at the bottom. So this is what is very, very important for you to notice. So if I wanted to make it in ascending order, I would have left it unattended, or I would have written it as ascending is equal to true. Next, look at this example where we can see the sort as well as head and tail example. As I told you that head by default carry 5, the top 5 rows of the series, and tail contains the bottom 5 rows. But if you specify the parameter, accordingly, it is going to change. So in the first example, if you notice the first print statement, before that, you just notice the data. Data is containing 4 names as indexes and 4 marks as the values corresponding to these indexes. If we are running this particular command where we are sorting it in descending order, basically, when we are saying ascending is equal to false, means it is descending order. So in merit, if I write final.head, it is going to display the entire data because we have less than 5 number of rows. So it will display the entire content of the data. But if you have large content of data, in that case, only first 5 rows would have got displayed here. Next, if you look at this, where we are saying head 2, it is only the top 2 students are displayed. If I say head 3, top 3 students will be displayed. If I write head 4, top 4 students will be displayed. So basically, along with head, the parameter which is there, it helps you to find out number of rows getting impacted with the function. In tail, the bottom ones are displayed. So if you say tail 2, from the bottom side, 2 will be displayed. So ME and bridge will be displayed over here. I hope this is clear. Apart from this, we can also have some min, max, min on series. So let's assume we have a stock series in which pen, pin, pad, and lead are there as the items acting as indexes, and these are the quantities of item in the stock. And if we simply display it with the help of print stock, it is going to be displayed as this, where you are seeing the order exactly in the same manner as it is there in the original data. Now, if we run the remaining commands, it is going to give you stock.sum is going to be sum of these values. Stock.mean will give you average or mean of these values. Max will give you the maximum, that is 100. And min will give you the minimum value, that is 60. And then count will give you the non-null values present in the series. So right now, all the rows have some values, and that is why you will be getting 4. Now, after series, the next important concept and most important concept of pandas is data frames, which is 2D data basically. A data frame is a 2-dimensional data structure. A data frame data is organized in a tabular fashion in rows and columns. Columns can be of different data types. Size of your data frame can be mutable, that means can change at runtime. Both labeled axis, that means in this case, your rows can be named by us, your column indexes can be named by us. So it is completely in our control what column headings we specify, what row headings we specify. In series, we have only row headings, and in data frames, we'll be having column headings as well as row headings. So you can see here, basically roll number, name, and marks are the columns, and these are the rows in which different data types. You can notice these are Maybe these may be integer type, these may be string type, these may be your float type or any other type. Even you can have tuple or list as the data type within a particular data frame. The syntax is quite similar here. Only one thing is getting added in the series. So if you notice, the entire syntax is identical, except the columns also got added here, because in series there is no concept of columns. Those are only rows. In case of data frame, you will be requiring columns also, and that is why you are allowed to customize the names of the columns also. Otherwise, the syntax is same. Let's see some examples which are similar in nature, as you have already seen in case of NumPy array as well as series. Here we have 2D array, so obviously we'll be having a nested list, converting it into data frame. So if we have a nested list, this will be considered as first row, this will be considered as second row, and the default indexes are going to be 0 and 1s, and default column labels are going to be 0 and 1. As I told you already, if you do not specify the customized names for your labels for row or column, they will be taken by default as 0 to n-1 as Python otherwise also follows for its all collections like list, tuple, and dictionary. Look at the second example. Here also we have 2D collection, but this 2D collection is of tuple, this 2D collection is of list. But when you convert it to data frame, both of them will be considered exactly in the same manner. You can see here, both of them will generate default indexes as 0 and 1, default column labels as 0 and 1. In this particular case, where you want to specify the names of the columns from your side, instead of 0 and 1, we want to call them as C1 and C2. So you will make a separate list with 2 elements in it, and these elements are going to be treated as the column labels. So you can see, instead of 0 and 1, now these column headings will be displayed as C1 and C2, whereas your row indexes remain unchanged because we have not done anything about it. In this particular example, when we want row index also to be assigned, so we are giving names to the row indexes as R1 and R2. So you can see in this example, we have a data which is 2D, and column headings are C1 and C2, and index for rows are going to be R1 and R2. So that is why when you will display, you will see non-default column labels as C1 and C2, and non-default indexes for rows you will see as R1 and R2. This is what is data frame mostly going to be all about. Now let's come to a meaningful example in which we'll be using non-default index, and this time we are making use of a dictionary to create a 2D data structure in which we are assigning name as the column heading and then giving these as the data values under name and marks. So you have to count how many number of data values are there. So the same number of data values should be here, otherwise you will get error. So in marks also we'll be having 4 values as the name has 4 data values. So if we simply write stu pd.dataframe bracket dt comma index 1 comma 2 comma 3 comma 4. So basically we are giving customized names for our column labels, and we are giving customized names for our indexes. If we will not specify, instead of 1 2 3 4, you will be able to see here 0 1 2 3. Okay, so if we'll display the values for this particular data frame, you will be able to see this content as name and marks as the column headings, 1 2 3 4 as the row headings, and Ami 10, Raj 9, Jed 7, Kaj 8 as the data values under name and marks. At the end, if you want to find out mean of only the marks column, in that case you can specify stu. Stu is the name of the data frame. Inside the square brackets, you specify the column label for which the mean is required. Obviously, mean of name will not make any sense. So if I write here stu inside the bracket and I write here name dot mean, it will not calculate, it will return error, because mean will be calculated only from the numerical values, not from the string values. So here, if we are finding out that, so it is going to add all of them together, divided by 4 and give you the result as 8.5. So mean is going to be calculated on only one column, that is marks in this particular case. So let's see data frame accessing rows and columns. So how we'll access rows out of a particular data frame and columns out of a data frame. So first of all, we'll type command stu.lock7. Just notice these are two different things. When we are simply writing stu.lock, that is location 7, we are looking for the customized index over here. So 7th index from the customized value will be picked up. That means this particular row is going to be taken away. When I say stu.ilock, that means actual index. Actual index is basically 0, 1, 2. So here we are talking about the second index. So irrelevant of whether you say stu.lock7, stu.ilock2, in this particular case, we are referring to this particular row, which is highlighted with yellow color. What will happen if you do that? You will be able to see the content like this. You will see sname, that is chair, and marks as 7, right? And at the bottom, you will see name. This name is nothing to do with the column heading. This name is name of the index for which the display has come. So this is the customized index value which will get displayed, and data type of it, as it is j and 7 are not going to be integer or string. It is going to be an object which is a collection, and that is why in data type you will not see int 64 or float 64 or str. You will be able to see it as object. Next example, let's look at. Suppose I am interested in finding out a column out from the data frame. So what we will do, we'll write a command stu and then specify the name of the column which is required to be pulled out. So if we write stu and then we write square bracket and specify this name, we will be able to see the entire column along with the index values, right? So index values will always come irrelevant of whether you are displaying MKS or you are displaying sname. So if you write in place of this MKS, in that case it will be 5, 6, 7, 8, 10, 9, 7, 8. In this case, we are saying sname. So what it is doing, it is just going to pull the indexes along with the column which is asked for, right? And at the bottom, you will see what got displayed. Sname column got displayed, and what is the data type of this sname column? Sname column data type is object. It is nothing to do with integer or float or string. This is another example of data frame where we are trying to access rows and columns with the help of proper commands. So we have a data frame created here with the help of 5, 6, 7, 8 as the indexes. If I write print stu sname, just see what gets displayed. When we say MKS, just see what gets displayed. And when you will say stu lock6, just see what gets displayed. So lock6 is Raj along with 9 as the marks, right? And the last, when you will say ilock2, this time it is going to display j, because when I am saying ilock, I am looking for the index which is the default index getting displayed. But as far as this content is concerned, this content is going to display the customized index only, always, whether it is called from lock or it is called from ilock. In both the cases, it is going to be displaying the customized index only, which is 6, 7 in this case. Okay, this is another example where we are going to see adding columns and deleting columns or rows. So let's assume we have a data frame in the similar way as we had. Suppose we want to add a column here. We can simply specify stu and a non-existing name in the column heading. So we already have two columns, one with the name sname, another with the name MKS. We want to create a new column and that carries name as GDS, that is grades. Okay, and then we specify same number of values which already exist in the data frame. So in data frame, we have 4 rows. So here we have to make sure that we fill in 4 rows here. Once we display this particular new column is going to be displayed at the end. So S name was already present, marks were already present, grades got added. Now after doing this, if I say stu drop 7, so if I am saying drop 7, that means corresponding to 7, every data will be deleted from here. So if we look at the content after this, you will see that except that particular row which was corresponding to index value as 7, all remaining data is going to be displayed. Next, suppose I want to drop a particular column. I want to remove marks from here, and I write stu is equal to stu.drop, and we write columns is equal to marks. That means this particular column will be moved out of this particular data frame. So if you look at the final result contain 3 rows and 2 columns. In this, marks column got deleted. So basically, you have to understand the command is going to be same. If you do not specify anything here, it will be considered as deletion of row. And if you want to drop a particular column, you have to specify columns as the named parameter and specify which column you want to drop. Drop means delete. Okay. For adding, there is no issue. Adding, you just have to find out if some column is not existing. Just make sure you add that column with the help of the syntax. You specify the data frame name, square bracket, write the new column heading, and then write the number of values same as the number of values already present in the data frame in each column. Okay. So this is very important for you to understand that deletion and insertion is extremely easy in case of data frame. At any point of time, any column can be added, any column can be dropped, any rows can be added, any rows can be dropped. Now, suppose you want to combine content from 2 different data frames. Suppose in one data frame you have list of students from one section and another data frame containing list of students from another section. If you have to add both the content in case of data frame, it is going to be extremely simple. Like in this case, you can see we have one data frame with the name S1, another data frame with the name S2. And if we want to add the content of both the data frames, provided both the data frames have same column names, we can simply write s1.append s2. And once it is done, you will be able to see the contents of both data frames as single one. So you can see this is the first data frame which we created. This is the second data frame which we created. And then what we got is finally both the data frames got added with each other with the help of append method. Next, arithmetic operations and sorting. So here you can see we have a data frame with names of students, marks of students, and we add one more column in the data frame which is carrying marks of another subject, suppose. And then if we write s1 dot one more column which is going to be result of already existing 2 columns, corresponding values of 2 columns. So here we can say s1 dot is equal to s1 mk1 plus s1 mk2. So the original table had only 2 columns in it. We added third column as marks 2, and then we added total as the last column in which the result of mk1 and mk2 got added. So irrelevant of how many values are there in the data frame, it does not matter. All of them will be added, or whatever operation you have mentioned in the expression, that execution will be done in no time. So you can see how the result is going to be seen by you. So first you will be able to see mk2 and tot. So in mk2 we have added a new column, and tot is the result of mk1 plus mk2. So you can just operate and see 21 plus 13 is 34, 22 plus 25 is 47, 15 plus 22 is 37. And if at all you want this to be sorted in descending order, you can simply display it like this, where your topper's marks on the top and the person getting the least marks at the bottom. So original data which we had in the data frame was only this much. Then we added one column with values and another column with expression. And finally, we sorted this particular data frame to be seen by us as merit list. Next, slicing and Boolean indexing. Now, slicing works exactly in the same manner in the entire Python, whether you talk about string, whether you talk about tuple, whether you talk about list, whether you talk about any collection, the slicing works exactly in the same manner. But in the previous examples of various collections, we did not go for Boolean indexing. That is what we are going to do here in Python Pandas. So wherever you want to refer or operation in Boolean indexing, you will be writing single pipe. Wherever you want to refer as AND operation, you will be writing ampersand symbol. Wherever you want to refer to not, you will be writing this tilde operation, tilde symbol. So just notice we have one particular data frame in which there is a column with the name A, B, C, D, E, and there is a column N which contains 10, 30, 20, 40, 20, and we have stored it as DF data frame. If we say DF 2:, that means second row onwards everything. So it is going to contain C, D, and E, because before this two indexes will be missing here because we are saying 2:. If instead of 2:, if we would have written :2, I would have got A and B with 10 and 30 as the data. If I would have written 3:, in that case, only the last two rows would have got displayed. If I would have written DF : -1, in that case, the bottom row I would have seen on the top and the top row at the bottom. The second example which you see in the print statement is DF N. N is one of the column name. Wherever the value of Dn is greater than or equal to 40, that will be displayed as true, and all remaining rows will be displayed as false. So you can see here the result. The first row, the value of N column is less than 40, and that is why it is false. This is also false. This is also false. As soon as you encounter 40, it is going to be turned true, and then at 20, it will again become false. So in one single step, you are able to figure out, suppose you are checking somewhere eligibility of people, whether they are eligible to perform some task or not, or whether they are eligible to vote or not, or whether they are eligible to get retired or not. So all those kind of conditions you can apply in one single go. You can just check here DF age greater than 60, and it will show you all those people who are going to be satisfying the eligibility criteria for retirement or selection or any kind of thing. The second example which you see here in the Boolean indexing is I have a DF data frame. Inside that, in the square bracket, I am putting two conditions here in the square bracket. First condition is wherever M is greater than M column is greater than B. M column is greater than B means C, D, E. And DFN is equal to 50, and in front of it there is a tilde, that means is not equal to 40. That means I am left with only these two, that is C with 20 and E with 20. So let's see whether we are able to see those rows of the data frame in which these two conditions are satisfied or not. So you just see here. So one is data frame M column is greater than B. That means A and B are out. The second condition is DFN in the N column, the value is not equal to 40. So these are the only two values in the column, right? So that is the reason you will be able to see only the two rows which are matching with the condition. So just in these two print statements, one very important point you have to notice here. In the first case, we are just checking whether that condition is satisfied or not. In the second condition, we are checking the condition, and based on that condition, we are displaying the content of data frame, and that is why that is lying inside, right? So both these are different things. In one, we are checking whether this condition is true for each row or not. In the second, if the condition is true, we are displaying those rows, and if the condition is false, we are not displaying those rows. So these are two different things, but both of them are making use of Boolean operations. This is another example. Let's assume we have class 6A, 6B, 7A, 7B, and the strengths are these, and the indexes are 1, 2, 3, 4. We want to see the first two rows. So if I say CLS colon 2, it is going to be displayed as before 2, all the rows will be displayed. Okay. Second one is all the places wherever the strength is less than 39. So less than 39 means this. So less than 39 is going to be 38 and 36. These are two rows. In the next one, I am making use of OR operations. In the previous example, we had AND operation. Here we are using OR operation. So either the class is 7B or the class is 6A, we should display that. So just see the example here, 6B and 7A got displayed. Next, let's look at this CSV file. This is a CSV file which we'll like to load in our Python program and make a data frame out of it. So let's assume that store.csv is a CSV file. You can see here the view of it in the notepad as well as in the Google Sheet. So to read CSV, we can simply write pd.read CSV, and this will be read in ITMS. And if I display ITMS directly, it is going to be displayed like this. And if I say tail2, it is going to be displayed like this. And if I say ITMS location colon means all, price and item to be displayed only, so it is going to be displayed like this. Okay. Now next is data visualization using Matplotlib. First of all, we'll be installing Matplotlib with the help of pip install Matplotlib. With Matplotlib also, there are a number of other packages will get installed. It is different that none of these packages will be using independently, and that is why I am not mentioning them. So Matplotlib is one of the most popular Python packages used for data visualization, a cross-platform library for making 2D plots from data in arrays. Can be used in Python ideally, IPython shells, Jupyter notebooks, web application servers also, written in Python, and makes use of NumPy, the numerical mathematics extension of Python. Matplotlib was originally written by John D. Hunter in 2003. Matplotlib is a collection of command-style functions that make Matplotlib work like MATLAB only. Each matplotlib function makes some changes to a figure. For example, if we talk about figure specifies the size. So it is 3 cross 3, 4 cross 3, 5 cross 3, 9 cross 3. So you can specify the column size and row size. Then PLT plot helps you to write an arbitrary number of arguments for plotting the figure. X label helps you to specify the label on the x-axis. Y label helps you to specify the y label. Axis helps you to specify the starting point of x-axis and ending point of x-axis, and then starting point of y-axis and ending point of y-axis. And plt.show is the ultimate method which displays the chart. This is the first example where we are making use of matplotlib.pyplot as PLT. So under that, we, as I told you, that plot is capable of accepting data as tuple, data as dictionary, data as list. So in this particular case, we are assuming that 10, 20, 15, and 25 are the values. So if we display it, it will by default going to have 0 to 0 onwards. There will be 4 values, so it will be 0, 1, and 2 and 3. That is the default index will be assigned. So you can see here the line plot is going to be 0 with 10, and 1 with 20, and 2 with 15, and 3 with 25. If we go further, we specify the x as well as y axis. In that case, we'll first of all here write those values which are going to appear on the x-axis. Here, those values which will be plotted on the y-axis, and then with the help of plt.show, you will be able to see on the x-axis A, B, C, D displayed values, and the values on the y-axis will be plotted. Then if we want to specify exactly from where to where will be the x-axis and where to where will be the y-axis. You can see here we are specifying x-axis to be drawn as A as the minimum and D as the maximum, and on the y-axis 0 as the minimum and 30 as the maximum. If you look at the previous example, the default was starting from 10 going up to 25, whereas in this case we are saying 0 as the starting point and 30 as the ending point, and that is why the graph is going to be little flatter as compared to the previous one, right? So pl2t.show, if it is missing, you will not be able to see this graph even if you plot it. Okay? So at the end of customizing all the specifications of any kind of graph, you have to write plt.show so that you can see the content at the end. Next, if you want to give specific labels for x-axis, y-axis, suppose on x-axis we are specifying sections, on y-axis we are specifying label as students, and the super title we are specifying as section-wise students strength. It is going to be displayed like this. Okay? You can see here, this is X label, this is Y label, this is subtitle. Then this is another example where we are making use of figure. We are specifying there is only one figure and the size is in the proportion of 8,4. So if we are displaying bar chart, so instead of plot, here we are writing plt.bar, and section is going to be on the x-axis, strength is going to be on the y-axis. So when you will say plt.show, you will be able to see the content like this. And then if we further specify the x-axis, y-axis and subtitle, it is going to be like this. Next, let's assume we want to make a pie chart. So first of all, you specify your section as ABCD, strength as 10, 20, 15, 25, and super title as section-wise strength. You can specify here a parameter as font size also. You can increase or decreasing according to your requirement. For making pi, you will be writing plt.pi and you will be specifying this variable quantity, that is variable collection over here. Then labels are going to be the fixed ones, that is section. Auto percentage, that is %f%%, and then shadow is equal to true. If you write, there'll be a little shadow behind your pie chart. If you write it false, that shadow will not appear over there. So you can see here, this is a pie chart with a very little shadow at the back here. Okay? It will look like this. Another example, if you want to customize the colors also, so you can specify if there are 4 values. For each value in the corresponding order, you will be specifying the colors. So we have specified light sky blue, yellow, green, gold, and red. And then if you want all of them to be combined together, then you will be specifying 0. If you want one of them to come out of it, then you can specify those with 0.1 or 0.2 so that that particular pie portion will be shown separately. So that is known as explode, right? So if you write this pie plot once again, and this time if you're writing st as the data, explode is equal to e. So basically this particular tuple where you are specifying for each of your variable value, if you are specifying 0, it will be intact with the center of the circle, and if it is 0.2 or 0.1 or 0.3, it will be moved away from the center in whatever proportion you have specified. Then labels is sec, that is sections will be labeled, and the colors, these are the colors associated with each of these values we specified. And then we write auto percentage, %1.1, f %, shadow is true, and start angle is 140. So basically it will be little slanted. So you can see 140 is this angle. So from here it is moving in this direction, right? So this is the 140 angle. So if I make it 180, it will be starting from the straight line here. If I say 0, it will be starting from this side. If you write 90 here, it will be starting from here. If you write 270, it will be starting somewhere from here. So basically, that is the starting point from where your values will be substituted inside the pie chart. So you can see here the explode is the 4th value which is exploded. So if I am writing 0.1 here, it will be little less distance between the center and this particular exploded slice. So this is going to be looking like. Then multiple plots. If you want to have multiple plots in a single one, then in figure size, you can suppose we are making each of them as a square figure. So if we have 2 side-by-side figures of charts, you will be writing 6,3, so that you will be having 3 cross 3 2 figures. Then you'll be writing plt.subplot. Now in subplot, you have to specify how many figures, and then within that, how many will be in total, and then this is the first and this is the second. So you can see here we have one figure with two different subfigures, and this is the first one and this is the second one. That is why it is 1 to 1. So if I have 3, it will be 1 1 3 1 1 3 2 and 1 3 2 1 3 3. And if there are 4, then we'll be writing it as 1 4 1 1 4 2 1 4 3 1 4 4. In this case, as we have only two subfigures, we are mentioning it as subplot 1 to 1 and subplot 1 to 2. In subplot 1 to 1, we are making a line graph, and in subplot 2, we are making a bar chart. So you can see here the way it is going to come. So the data I am using same, but in your case, you can use both these plots with different data. So if you want two plots side by side, you can make use of subplot for that. Next, if you have 3, as I gave you example previously, as 1 to 1 and 1 to 2, here it is going to be 1 3 1 1 3 2 and 1 3 3, because in one picture we have 3 pictures. And this is the first one, this is the second one, this is the third one. So here we are making a line chart, here we are making a bar chart, and then last one is the pie chart. So you can see in one single picture, all 3 of them. So this is a single plot, right, with 3 subplots. So if we had 4 of this kind, then I would have numbered it as 1 4 1 1 4 2 1 4 3, and the next one would have been 1 4 2. But accordingly, I have to make this proportion also right. So in that case, I would have kept it as 12,3, so that on the row side I'll be having 3 proportionate to 12, right? So that we'll be having 3 cross 3, 4 different subplots in that case. So this is what is going to be output of this. Next is making use of series for making the plotting of bar. So let's assume we have a series which is carrying index as A, B, C, D and data as 10, 20, 15, 20, 25. We write PLTD, that is your series object. We write plot kind is equal to bar, and then we specify title, X label, Y label, and so on. And when you will say PLT.show, you will be able to see this particular bar chart like this. Now, if you want to have multiple bars together, in that case, you can make use of a dictionary, make a data frame out of this dictionary, and then you specify plot data dot plot kind is equal to bar, and then title, X label, Y label, and then at the end, when you will say PLT.show, you will be able to see the multiple bars together for different years. Okay, like this. Then if in the same one, if you add one more option at the end as stacked is equal to true, with kind is equal to bar, if you add another argument as stacked is equal to true, you will be having this kind of stacked bar chart. So the previous example and this example is exactly same, except one more argument over here as stacked is equal to true. So this is what is going to be output. Now there are 2 more simple examples. Suppose you want to make a sine curve with the help of Matplotlib. Then you can simply make a NumPy array with range as 0.0 to 2.0 with a step of 0.01 for a smoother curve. And then you make S as another NumPy set of values, which is carrying 2 into np dot pi into t. That is basically from here, whatever variation of angles you are picking up, accordingly it will calculate the sine value of that, and then it will substitute in plt.plot. So you'll see each dot will be very close to each other, and you will be able to see it as a line only. And I am giving the limit of this as minus 1.5 to plus 1.5. Actual values are between -1 and +1. I'm giving little extra gap so that on top as well as at the bottom, you will be able to see some space So your curve is going to be like this. This is the sine curve. You can see as we have kept the variations very, very small, and that is why you do not see any gaps in between. You are seeing a continuous curve like this. If you wish to make cost curve at the same time, you can just add one more line here. So as we have written S is equal to np.sine, you can write C is equal to np.cos and plot for both. So this is going to be plotting sine curve, and this is going to be plotting the cos curve in the same graph. So if you notice, it will automatically get displayed with two different colors. And if you just change it to -1 and +1, in that case, the top space and bottom space will vanish. You'll be able to see the curve very compact. If you say -2 and 2, you will be having more space on top and more space at the bottom, right? So that is entirely up to you. And if you want it up to only one cycle, you don't want it up to 2 cycles, then in that case, you can vary it from 0.0 to 1.0 only. So you will be able to see this curve only up to this point, the highest point. Okay. And if you want more cycles to be seen by you, then in that case, you will be changing it to 4, 5, 6, whatever number. So that many cycles of sine curve as well as cos curve we'll be able to see. With this, we end today's session. I hope we were able to share with you enough examples to work on. And once again, I thank Mr. Mohit, Mr. Rajesh Sethi for making it possible, and a special mention to one of our students, Vidur Sahni, who keep giving us some musical inputs for starting this session. And thanks once again to all the participants to make it possible. And it is only for you we are able to put in so much. And this is a social and education initiative by all of us for all the computer science teachers teaching informatics practices and computer science. And those who have not joined Python for +2 group, I would request once again all of you to join Python for +2 group, because it is a group of all computer science teachers where all computer science teachers help each other with answering questions and putting their own questions and sharing their ideas and knowledge. So enriching everyone. And there is a blog also on which all the previous Meet YouTubes are available. That is csamazingresources.blogspot.com. So you can just visit this blog to view the previous contents. And look forward to see you in the next meet. Next meet, we are going to cover the remaining portions of data structures from computer science. So look forward to see you in Meet 7. The date is not decided yet, but soon we'll come out with the date and we'll intimate you on your email addresses as well as on Python for +2 group. Thank you once again.